Hi, I'm Nicole and I'm a postdoc in applied maths in UCD, and today I thought I'm going to give you a bit of an idea what my research is about, but since Halloween's just around the corner, I also thought I'd talk about something a bit scary, but then I actually noticed for some of you that might actually be the same thing. Honestly, if I would get €1 for every time somebody tells me they're bad at maths, that combined with my postdoc salary would actually add up to a living wage. There's just so many people telling me, oh, I just never really got maths. And what is it even you're doing with your time? What are you researching? Do you try to invent a new plus or minus? Which I, of course, don't. What my specialty is computational maths. So I've developed a strategy how to talk about it, which I think might be a bit less scary to people, which is, of course, assuming that the scary thing about me talking about maths is actually the maths and not just the German accent. So I do tell people I train computers to solve equations and do computations. Because, for one, I feel like computers is just ones and zeros. It's either electricity flows or not. That's very simple. But also, we're so used to using computers to do some form of computation every day. For example, if it's the machine in Tesco's that tells you how much change you get back, or whatever you put into the fitness apps on your phone that tell you if you're still okay if you drink that second cola. But there's also other areas in life where computational maths plays a big role. And one is that we do depend to a certain degree on numerical simulations. But before you get a fit for your tinfoil hat, this is not about the matrix or how we live in a computer simulations. What I'm talking about is tsunami warnings, it's flood forecasts, it's storm forecasts, and weather predictions. And as an immigrant, let me tell you, the Irish people do love the weather. And for some reason, also the disaster that it sometimes brings with it. I'm not sure if you remember, but 2 weeks ago, we had Storm Lorenzo, and everybody got really excited about, oh my God, Lorenzo's gonna come, it's gonna be here on Thursday, and then you go on the internet and you try to find every piece of information you can possibly find, and then in the end what happened was nothing really, or mostly. So it's basically like we were all stood up by a Tinder date. But yeah, that's just because storm simulations or storm predictions are so difficult and so hard. And the reason for that is that you might have heard about Edward Lorenz and the butterfly effect, that some of these systems that we try our computers to solve are just inherently chaotic. So no matter how good and accurate your computer is, there will always be uncertainty. And the only chance you have is try to train your computer to do the computations better to reduce that uncertainty. And the way we do that at the moment is to run what we call ensembles. Well, thank you, 5 years of high school French. That means you run the same simulation many, many times, slightly change the input parameters, and then you average over all the results you get, and that in total will give you a better prediction. And this is basically where my research comes in. I do research ways to solve equations more accurately on computers, but also to look at computer codes and try to make them faster so that we can ultimately run more simulations in the same time, or just run more simulations in general so you have more results to average over. The one thing I'm mostly interested in, though, is not the actual wind or the storm, but water waves. And that's because it's been shown that during big storm and flooding, it's mostly the water that causes the most damage. I'm talking rainfall, river flooding, or just really big waves caused by really big storms on the coast. And one of the most prominent big storm types are tropical cyclones. We've all seen them, these big rotating systems of wind that push lots of water towards our coasts. And when these systems reach speeds of over 120 kilometers per hour, we call them hurricanes, and then we give them names, and that's what we see in the media. And when you think about it, 120 kilometers, that's pretty fast. That's the speed limit on the Irish motorway, right? Okay, it's maybe not fast for me because, German and the Autobahn, but, 120 kilometers, you probably don't want to get too close to these storms. Luckily, in Ireland, we do not get many hurricanes here. If you remember 2 years ago, Hurricane Ophelia wasn't really a hurricane when she came here. So all we get is just dying hurricanes or remnants of hurricanes. And the reason being, it's just too cold here. It is. So what that means for us is hurricanes don't cause anywhere near the damage they cause on, say, the east coast of the United States. So we only have maybe a few days of very inconclusive weather forecasts, plus maybe a few more memes of, for some reason, people fighting over sliced bread in supermarkets. So ultimately, I think what we would need is a Batman-style supercomputer that can measure and predict the weather and all the waves. And one thing I do in my research is try to predict these storm and flood events by looking at them as little as possible. By the way, looking at surroundings as little as possible is also my neighbor's favorite way to park their car. What I do work on is trying to train my computer to exactly know the few points where to look so that this looking up data is very fast, but also the result is pretty accurate. So hopefully one day we will be able to have a James Bond villain-style supercomputer, maybe a weather and wave machine, if you want to call it like that. But until then, I think we need to work on computational maths, and that computational maths definitely is the way to go, and that it's not scary at all. Thank you.